I'm going to teach graphing today. It's chapter 7 in somebody's book. So graphing is really straightforward if you think of it in terms of a grid, like a coordinate system. It was originally created by René Descartes, who's credited as the Cartesian coordinate system. Descartes, Cartesian. He was French, and so am I. No, just kidding. Bonjour. So we're going to do this now. We're going to do a couple things. One thing, if you're thinking one dimension, okay, way back in sort of basic stuff, one dimension, you have what's called a number line. And you remember real numbers, right? They're everything that's on the number line and everything in between, and everything around the number line, okay? Let's look at the board and draw a number line. So we have numbers, right? And then we have numbers like what? Yep.
1.
1, 2, 3. The first counting numbers. 1, 2, 3, 4. Oops. There you go. We have some Frenchies out there. Okay. And then we developed what? We developed on this side? Negative numbers. -1, -2, -3, etc. Right? Integers. From there, somebody noticed somehow that there were little intervals in between the numbers. And what are those called?
Decimals.
They're called decimals, or these are the bane of every algebra student's existence.
Fractions.
No, it was fractions, right? These are integers. Fractions like 3/2, -1/2. And we had decimals, of course, like 3.5, right? And we had, what are irrational numbers? Anybody know what an irrational number is? A number that doesn't make sense?
Like
What kind of?
3.4, 3.5?
Yeah.
3.3.
No, that's a repeating decimal, so that's rational. But you're on the right track. You're on the right track.
Would it be like pi?
Pi. What is pi? 3.14 something, right?
Yeah. Except
Yeah, okay, and then a bunch of numbers that we don't know. I know it could be anything, -2.123 10 or 9, 7, etc. ... Those are numbers that you don't really, that you can't capture them in a way that will make any sense. You don't really ever know what it's going to be equal to unless you round it off. So it's an irrational number, okay? So that'd be right there. Okay, so those are the real numbers, okay? Real numbers, and that's the symbol for real numbers. Real numbers. Now what would happen? That's only in one dimension, right? This is 1D, okay? What happens if we go to 2D? Well, here's our number line. Let's start with one dimension. Now how do we create, okay, we've got 0, 1. Everybody should write this down too. 3, -1, -2, -3. Everybody write that down.
Okay.
Now, let's go into another dimension. How do we create 2 dimensions out of this? What do we do to create 2 dimensions, Taylor? How do we create 2 dimensions? No idea? What, Allie?
I don't know either.
Sure. Yeah, Emily?
Do you make a line the other way?
Yeah. How about like this?
Yeah.
And guess what? That's another axis. That's what you do for a Cartesian coordinate system. And then you can make numbers here as well. Okay? All right, so there's your Cartesian coordinate system, right? You've got your plane, it's called, right? And that's 2 dimensions. And this axis we call the x-axis. And this one?
Y-axis.
Y-axis. Why? Because it follows
X.
x. Good. You getting this down, Kia? Okay. All right. Everybody clear on this? Taylor, you got that? Right, now, we want to find points on this plane, right? So how do we find them? Remember the stick shift driving example we gave? We started at 0. This is now 0, 0. Okay? But this is the point, the origin. Okay, this is 0, 0. And that's also called the origin. Now, what about another point on here? That's what we put right there. How do we find another point? Can anybody find a point on there? See, when it was a number line, a point was just a number, right? It could have been a fraction, it could have been any number, but it was just a number. Now, we're talking about a pair of numbers. They're called coordinates. Allie?
2, 3.
2, 3. Over 2. Which one do we go? Do we go up first?
Up first.
No, we go over first.
Over first and then up.
And then up.
2, 1, 2, 3. So there we go. There it is.
Unless it's negative.
2, 3. Well, even if it's negative, you still go right or left first, and then up or down. Always, remember, on your stick shift, it's right or left, and then up or down, okay? Yeah.
I have another one.
Okay, you've got another one. 2, 3.
No, like another, like, how to remember it.
Okay.
You have to crawl before you walk.
You have to crawl before you walk? Okay, how's that? This is crawling and that's walking? Okay, that's good. That sounds good. Yeah,
Oh. I'm not forgetting.
okay, no problem. Nadia, you getting this down?
Yeah,
Writing this
she
down?
has it.
Okay, good.
Um,
Now, let's do a negative one. Well, let's get a negative coordinate, yes.
So you go over and then up.
Yes.
Or over and then down.
Right, left, and then up and down.
Okay.
So here, let's do -2, -3. We go over to the left and down 3. Zippity-doo down. Okay. Left 2 and down 3. Fair enough? And this was right, bloody well, right 2 and up 3. You got a bloody right to say, all right, you're bloody well right. Okay, so there you go. Now guess what? These 2 points can be joined up and we can make a what? If we join those 2 points, we can make a line. Right? Right?
Yes.
Right. So let's do that. There we go. A little crooked, but there it is. Those 2 points are on the same line. We just joined them up. All you need to have is 2 points to get a line. That's all you need to have is 2 points to get a line. So we've got a 2-dimensional system, a 1-dimensional system. We've got 2 points here. We've got a line because we joined them up.
Is there a 3-dimensional system?
That's another thing. 3 dimensions would be another axis, and that's a z-axis, but we're not going to get into that now. That happens later in calculus. Negative.